Yes. Okay, so this is the lesson that I would have given on Friday. Well, it would have been on Friday. Not sure whether it would be in the morning or the afternoon, actually, because the last one was quite quick. So we'll just put Friday the 20th of March. Morning or afternoon? Probably morning. I'd have gotten to this one in the morning. Right, so it's lesson 66, page 462, iterative root finding. So if an equation x equals g of x has a solution alpha, so that means if you put alpha there and you do g to this value of alpha, if they're both the same, so the g of the alpha is the actual alpha, then you can use an iterative formula written as, okay? So written as x to the n plus 1 is g of xn to solve the equation numerically. Again, this becomes clearer with an example. But basically, x to the n is the value that you've got. You apply g to it. You do g, whatever, if it's x cubed plus 3 or whatever. That will give you the new value. And then you put the new value in, apply g to it, and you get another value. And you go round. That's an iteration. You go round and you'll get a sequence x2, x3, etc., and they will converge to an alpha if the starting point is a sensible one, close to alpha. Okay, so a sequence will converge to alpha as n increases. So a sequence converges to alpha if, as n increases, xn gets closer to alpha. This will become clearer with this example. So what we've got, a convergent sequence is defined by xn plus 1 is a half xn plus 2 with x1 equals 3. Okay, so we've got x1. We're told what the first value is. Okay, so the next value, x2. So we put this in here. We've got the x1. And look, so n is 1. Sorry, n is not there. N is 1 is here. Because if you put a 1 here, look, x1 plus 1, x2 is a half of x1, because n is 1 plus 2. So it's a half of x1 plus 2. So it's a half of 3 plus 2. So it's 1.5 plus 2 is 3.5. And we can do the next one, n equals 2, gives us x3. So it's a half of the previous one plus 2. So it's a half of 3.5 plus 2, which is 1.75 plus 2, 3.75. Okay, and then n is 3, gives us x4. So this is going to be a half of x3 plus 2, which is a half of 3.75 plus 2, and that's 3.875. So you can see we start at 3 here. The next one is 3.5, 3.75, 3.875, etc., etc. So you can see that it's closing the gap all the time. Okay. In the book, they give you further calculations. So further calculations would show that x10 is 3.998 and x20 is 3.999998. So it appears to converge to 4. And get closer and closer to 4 without actually ever being 4. Okay. To check if it's 4, if we say, if it is 4, then xn plus 1 is 0.5, xn plus 2. If it converges to 4, if we've got 4 here, and 4 here, it should be like the same. It should be the same if it's converged to it. So if we've got so when it converges at the limit, we've got L is 0.5 L plus 2, because at the limit xn plus 1 is xn. Okay, so it means that it doesn't, when we've reached the limit, the next term is the same as the term we've already got. So what we'll do is solve this equation, take half L away from each side, 0.5 L is 2, so therefore L is 4, so the limit is 4. Okay, and C, if we let x1 be 100, x2 is going to be 0.5 times 100 plus 2, which is 52. x3, 0.5 times 52 plus 2, so it's 26 plus 2, which is 28. The next one, x4, 0.5 times 28 plus 2, so that's 14 plus 2 is 16, etc. If you look at so the next one, x5, half times 16 plus 2, which is 8 plus 2, which is 10, and then we half 10 plus 2, which is 7, half of 7 plus 2, 5.5. It appears to be, it's creeping in to 4 from above, which is what I thought it would. Half of 5.5 plus 2, so it's 2.5, 2.75. Look, it got there, 4.75. Yeah, it's gonna go to 4 from above. So draw diagrams showing these convergences. So I need more paper here. Draw diagrams showing these convergences. I can do the diagram for A up here. So we've got, it's where we need to find, it's where x is equals to a half x plus 2. So half x plus 2 looks something like this, and the graph of x, so that's the line y equals x, that's the line y equals a half x plus 2. That actual answer is 4, because we know that already. Okay. So the first one, when we start at 3, we go to, we put 3 into this side. We put 3, we start by substituting 3 into here, which is, it's this line, the half x plus 2. So 3 goes into there. I need to zoom in a bit here. And then it becomes, that becomes our new x. And then it zooms in again. It's not a very good diagram, that. Let me just start again with that one. And draw this line here. So half x plus 2 looks like that. Let's zoom in, and y equals x is at 45 degrees, like so. I'm going to put it here, I suppose that's 3. Okay, yep, I suppose that's 3. So we're looking where x equals a half x plus 2. It's a bit messy, that's the a half x plus 2 line, and that's the xy equals x there. So we substitute it into the, we start by substituting 3 into the right hand side, which is that one, that's the right hand side, and then that becomes the new x. x. Then we substitute that one into the right-hand side, etc., etc. So I think you can see that a bit better now. That makes a staircase. It's called a staircase diagram, okay? And that is an official maths word. Staircase diagram, we start with one value and it steps in to the 4 eventually. Right, this diagram, the 100 one, I don't think this I must have taken this from another book, because this isn't quite the same as the book. The book only does A and B, it doesn't ask for the diagrams, but I'm doing them anyway, because that's the diagram for A, so the diagram for C. So again, we've got the same 2 diagrams. We've got y equals a half x plus 2 and y equals x, like so. If we start with 100, which is out here, okay, so this is the right hand side line, this is the left hand side. So we put the right hand side, it goes into the right hand side, and then that becomes the new x that we substitute in. Right hand side, so we get to the 4, that's the answer 4. We get to the answer for staircasing from the right, from the 100 down to the 4. Okay, so that one is also a staircase diagram. Okay, there's 2 types of diagrams that you can have. You can have staircases and you can have cobwebs. Proper official maths words in level 3, and I will, hopefully there'll be a cobweb one on the next page. Right, okay, so staircase or cobweb diagrams can be used to display iterates given xn plus 1 equals g of xn. So to draw this, we draw the curve. The other ones were straight lines, but more generally it would be a curve. So we've got a staircase diagram here. I've just drawn these really. It's always y equals x is always on the left hand side. So it's the left hand side is always y equals x. And then you've got a curve. And it's finding where the curve meets the line. Okay, so we start with a value, they call it x1. And this is actually this is called alpha, where they actually meet. So x1, that one is the right hand side, which is some fancy function. You put it into the right hand side, and that gives you a new value to put of x, to then substitute into the right hand side. Okay, so it's slightly different, that one, because it's I've done it as a curve rather than a line and a line, because that's more general. Okay, now a cobweb diagram, which I mentioned before. This one, let's draw this diagram here. Again, we've got the line y equals x. Oh, that missed. It's got to go through there. It's got to go through notes. I'll sort of colour that in a bit there. Okay, and then these ones. Nope. This one goes down like this. Okay. So what happens with these ones? So again, we start with a value x1. That would be x2 there, you see, that's the second value of x that we get, and x3. And you can keep doing this, and eventually you'll get to alpha. So this one, we put this into the left-hand side, and then our new value of x is actually comes across there, because that's at the same height. So then that one goes in there, so that's x1 over there. Which so it always goes curve, line, curve, line, curve, line, curve. And this one's called a cobweb diagram, because eventually it spirals in to the solution. Okay, so the curve is that one, x, that's the left-hand side, and that's the right-hand side. So we start by substituting the x into the right-hand side, and then you take that value of x and substitute it in again. So it gives you that there. So that's x1, that one's x2, and that one's going to be x3. Okay, etc., etc. Okay. Example 3. Example 3. Looks like a bit, it's missing here. 3a1. It says show that the equation f of x equals 0. Well, I haven't written in what f of x is. F of x equals x cubed minus 6x plus 2. So show that the equation f of x equals 0 can be rearranged into the form x equals x cubed plus 2 over 6. So A part 1, we've got x cubed minus 6x plus 2 equals 0. Okay, see, with this numerical iteration method, you can solve all sorts of equations as long as you can rearrange them and get an x on the left and everything else on the right. Sometimes they work, sometimes they don't work, but you know, this is it's what we've got to do. So if we look at what we want here, we want that x equals x cubed plus 2 over 6. Well, look, there's the x cubed and there's the 2, and they're together, both positive on one side, divided by 6 and the x on the other. So by that, I'm going to say x cubed plus 2, leave that on the left and add 6x to the right. And then we can divide by 6. So we can say x is x cubed plus 2 divided by 6. Okay, and when you've got something like that, you can then change it. You can say xn plus 1 equals xn cubed plus 2 over 6. When you've got it in that form with the x on the left and everything else on the right, rearranged in the right way onto the right, you can make an iteration. So we start with x1 is a half, and then find alpha to 2 decimal places. Okay, x2. So we have to keep going through this iteration until the answers rounded off to 2 decimal places are the same. So x2 is a half cubed plus 2 over 6. Well, a half cubed is 1/8, 0.125 plus 2 divided by 6. I'm going to use the answers in the book. I don't have to calculate all these every time. They say it's 0.35. Okay. x3 is 0.35 cubed plus 2 divided by 6. Now, I'm not sure if the book's rounded off or anything there. So use your answer button. So in there you could put ants, is probably the better thing. If you use the answer button on your calculator, you'll keep it exact. So x3, they've come up as 0.34, but if we use our answer button, the unrounded off version, that would be better. And when we do x4, we do ants cubed plus 2 divided by 6. That's also 0.34. The book's actually gone on to show that x5 is 0.34 as well. But I would stop there because they've got one answer is the same as the next answer. We can say that x cubed minus 6x plus 2 equals 0 when x is 0.34 to 2 dp. Okay. So that's all part A there. It's another colour, it's a bit of variation. Part A. So part B is going to have to be on a new page. page and I'll do part B on a new page. There we are. Oh, that was good. Right, so part B, I'm going to do on this page. So I've just copied the page over. So part A is here. I'm going to do part B now on this page. It says, show that the equation fx equals 0 can be rearranged again into another way. The square root of 6x minus 2 divided by x. Okay, let's do that then. Oh, and our f of x was x cubed minus 6x plus 2. So if we've got f of x equals 0, x cubed minus 6x plus 2 is 0. So this rearranging, we've got a 6x minus 2. And it's a plus 6x and a minus 2. So I'm going to start by getting that in there. That bit that I've just mentioned is that numerator there. Okay, so x cubed is 6x minus 2. Now we've got to divide by x. Next step, look. Let's change the colour there. So divide by x in this next one. So the green was the first thing that I did. Blue's the next one. So x squared, 6x minus 2 divided by x. And look, we've got it then. So we can say x is the square root, 6x minus 2 divided by x. Okay, so that's also an iterative. Comment on the suitability of the iterative formula with x1 equals a half for estimating alpha. Okay, so x1 is a half. So this, we can say here that xn plus 1 is the square root 6xn minus 2 over xn. So x2 is square root 6 times x1, 0.5 minus 2 over 0.5. So this is actually the square root. I can do this one. 6 times a half is 3, minus 2 is 1, divided by a half is 2. But again, I'll use the answer button. So that's given us, from a half, we've gone to root 2, so that's approximately 1.4. I've got the answer in the book actually, 1.41. But use the answer button. So x3 is going to be 6 root 2 minus 2 over root 2. I definitely can't do that in my head. X3, 2.14 to 2 decimal places. But again, use the answer button. So we've gone from a half to 1.41 to 2.14. I'll use the book. X4, a similar process, give us 2.25. So what they've done there is they've put 2.14 in here. 6 times 2.14, or 6 times the answer, minus 2 divided by the answer, square root, rounded off, 2.25. And then they've said x5 is 2.26 and x6 is 2.26. So we've converged to a different root. The previous page we converged to 0.34 for x. This one we converged to 2.26. Okay, so the reason for this, so this one, this second iterative here gives us a different value of x. Okay, converges to a different value of x. So when it says for estimating alpha, alpha is, we've got two values. We've got a 0.34 and a 2.26. So this cubic, and it says here the graph of the cubic shows that f of x equals 0 for two positive roots. Alpha is about 0.34 and beta 2.26. So if you sketch that on the internet, you would see this. This goes through and x is 0, y is 2. Okay, so this cubic's going to look something like this. Okay, so part A gave us that one, part B gave us that one. So it all depends on how you rearrange it, which one you get, as to whichever one you get. Okay, one more question here. Example, it says, Oh yeah, the examples there. We can use the gradient of a curve to determine if x to the n plus 1 equals g of x n converges to the solution alpha. Okay, so if g dashed of x is between -1 and +1 for all x in the interval which contains alpha, and the starting value x, then it will converge. Okay. We've got a diagram for that. It feels like you need a diagram. They've just done it as a key point. Yeah. Hopefully become easier with the example. So the equation x is x cubed minus 2 has a solution alpha near 1.5. Okay. Show that the sequence produced by xn plus 1 equals xn cubed minus 2 with x1 equals to 1 fails to converge to alpha, and explain the cause. Right, the cause is going to come from this key point. Okay, so I know that that's going to be there. But we'll look at the sequence first of all, and we'll come back to that key point and explain what's going on using that idea in a minute. Right, so xn plus 1 is x cubed, xn cubed minus 2. x1 is 1.5, x2, 1.5 cubed minus 2. Right, this is a different question from the book again, so I'll do this on a calculator, it's not the same. Right, 1.5 cubed minus 2 equals 1.375. Answer cubed minus 2. x3 is answer cubed minus 2, which is 0.5996, etc., etc. Answer cubed minus 2. x4 is minus 1.7844, etc., etc. Okay, so it's not going to converge to, these might be different numbers than what's in the textbook, but it's the same idea. It does not converge. I think there was 2 copies, and I've got a new copy, and this was probably based on the old copy. So this does not converge. Okay, so part B, that was part A. It's going to get more and more negative, you see. It's not going to converge because we've got a negative number cubed which stays negative, and then you take away 2, so it's going to become more and more negative all the time. So it's just, you know. The cause of the failure: if -1 is less than g dashed x is less than 1 for all x in an interval which contains alpha and the starting value x1, oh, I didn't read the question properly. No, it's fine. Right, B. G dashed of x is 3x squared. Okay, and the reason for that, look, this is G. G is this right-hand side, and you differentiate that. It's 3x squared. Okay. If we've got g dashed of 1.5, it's 3 times 1.5 squared. 1.5 squared is 2.25, so it's times 3, 6.75, which is greater than 1. So hence, using the key point above, the iteration will not converge. I slightly paused because that does say x1 equals 1, and I started with 1.5, but you still get a similar answer. It'll just be different numbers, and I don't want to do the whole of this video again just for that sake of that. But this one, you can see that answer on page 466 of your textbook, so you can check for the details there. But you'll see it's exactly the same. and part B isn't unaffected by that. Okay.